Well, hello everyone, welcome back to Adrian's Digital Basement 2. On today's video, we're going to be recapping this motherboard here. This is a Macintosh Classic II motherboard, and I'm working on a Mac Repair-a-thon series on the main channel, and I tested out this motherboard in the Classic II, and as usual, the Classic II, as is the Classic, is unreliable because of all this usual stuff. So I wasn't going to show this on the main channel because I had just done a recap of another classic motherboard, this one right here, the Classic I. And it's essentially the same amount of work, but I figured I'd do this one on camera for the second channel because I think some people might want to watch me just do a mindless recap here. It's pretty easy stuff, so that's what we're going to do today. Unfortunately, at the end of this, I'm not going to show this motherboard working or not working because that is going to be on the main channel. Now here is the motherboard in question. If we zoom up a little bit, let's just see the corrosion and everything that's actually on this. This motherboard's in actually worse shape than the Classic I motherboard was. Look at this, if I zoom in here, we got green crusties, we got all sorts of goop on here. The board itself is very dusty, so you can see very clearly where the leakage has gone all over this thing. So this whole area is looking not great. I mean, I don't like those green crusties there. At least it just seems there, and over here on the RAM. And over here, it's the same story. Not looking good. Now this thing uses 10 microfarad, 10, that's a 10. I know it's hard to read because of the contrast there. This is a 47 at 16. Over here, we got a 10. Let me put on my goggles because I'm having trouble reading it. We got 10, 10, 1, 10, 10, a 1, a 10, and a 47. So we're going to be using these caps to get things replaced on here. So these are 47 microfarad ceramics, so that's for the 3 of those. These are 1 microfarad aluminum, so we got, how many of those? 1 there, 1 there, that's it. Just 2. Okay, so 2 of those. And then for the 10s, I'm going to be using these 22 microfarad at 16 volts. Now, the reason why I'm using higher is because these ceramics, they don't really, well, they don't give you the 22 microfarads at the voltage you would expect. Let's go look up this particular part number on here and let's figure out how the characteristics of these. All right, so here is the cap, a Venkel, 22 microfarad, 16 volts. We got to go to the data sheet though to see the problems I'm about to talk about with these ceramic caps. And I didn't really know about this, to be honest, because I'm no engineer, until a viewer reached out to me and just let me know that these multi-layer ceramic things just don't really behave the same when it comes to their capacitance value at the same voltages as regular electrolytic caps. When looking through these, this data sheet kind of sucks, actually. It doesn't really talk about what I'm trying to show here. It just has a bunch of curves that show the capacitance versus temperature, which, yes, I know that's going to change over a temperature range, but it's not super dramatic. I need to look at a different data sheet. We'll look at the one for these caps right here, which I think are Vishay brand. They have better data sheets. Oh, actually, they're not Vishay, they're this brand right here. Okay, this is what I was talking about. So this is the DC bias characteristics, and this here is the change of the rated capacitance. So say, I think these ones here are rated at 47 microfarad. Well, around 2 volts, you're gonna get 47 microfarad out of these. But at 5 volts, you're only gonna get, well, minus like 30%. But worse than that, these ones here are rated for 16 volts, and at 16 volts, it's like minus 70% of the capacitance out of these. Now, luckily, when we're using these 47 microfarad caps on this motherboard, they're generally gonna be running at 5 volts. There's probably some of these that might be running at 12 volts, I don't know, for the disk drive or whatever. So that's not that big of a deal because the disk drive that's plugged into the motherboard also has its own capacitors on it. But you're losing a lot of the capacitance at 12 volts, and even at 5 volts, you're losing more than you would expect. So with these 47 microfarad caps in their normal use on the motherboard installed, you're only going to be getting around 32 microfarads. Now, aluminum electrolytic ones don't really behave that way. I think they're pretty much fine all the way across the board. Now, the reason why I wanted to upsize the 10 microfarads to these 22s is A, I have a boatload of them anyways, and B, if we're gonna consider that these have a similar curve where at 5 volts, they're also gonna lose like 30% of their value. Well, that means that these 22 microfarads are going to end up around 17 or so microfarads. And I don't have the exact curves for these, but we can just assume it's going to be the same. Now, I also have a roll full of 10 microfarad of these, and if we put those on here, then we're going to end up around 7 microfarads. I don't know which is better to use, but I'm just going to try using these 22s, and we'll see how that goes. And I suppose if the machine is misbehaving, then I can try taking them off and putting on 10 microfarads. But I guess I'd rather be a little bit high with the capacitance than low. And when it comes to these 47 microfarad caps, if I had some 68 microfarads of this particular variety, then I would just use those instead, because when you take the 30% off of that, it's a lot closer to the 47 that the value is spec'd from Apple. Anyhow, when it comes to recapping this motherboard, the method I like to use is the wiggle method. Now on this motherboard, I don't always do this, but on this one, I'm gonna take a picture first. I wanna make sure I have a record of exactly the orientation of all the capacitors on the board. Of course, I have video footage that I'm recording right here, but just in case. So I like to use the wiggle method, and the wiggle method is you just grab them with needle nose, and I'm gonna grab, push down, and just turn back and forth. I'm trying to metal fatigue the little legs that are underneath the cap. And with enough of that, there you go. That just came right off the board. Let's zoom in a little bit so you can get a better view of what's going on, but you can see that that did not cause any kind of damage to the board. Well, there's already damage to the board, but that was done by the leaking caps, not by the wiggle method. And we'll just get these things off of here. I like this method. There you go, cap 2 off. And I just keep on going. I'm going to do this small one here, and then I'll take off the big boy. Yes, take off the big boy. So recapping like this, it's kind of boring. There's not a whole lot to it. You just got to take these off. You got to clean up the mess here. You got to make sure there's no traces that have been eaten away. And there's not much to it, to be honest. Of course, I'm lucky enough to have enough of these machines floating around that I've been able to try this stuff enough time to kind of get comfortable with it. And believe me, when I started doing it, I was way less experienced than I am now. I mean, it's not like I'm as experienced as some people who say recap these boards for a living or something like that. But I have learned that if you try to take these caps off using hot air, then that is very likely, at least in my experience, to rip traces, lift pads, and just generally cause a nightmare. Not a nightmare. When you have a lifted pad, it's not the end of the world. It's just annoying. It's just extra work that you didn't originally have to do if you didn't lift a pad. So there we go. See, these are all coming right off. I mean, wow, is it crusty under there? Sometimes they just don't want to come off, and then I will try to twist them around. This one is disconnected on one of its legs. The other one, it's just holding on for dear life. There we go. So there we go. Look at that. Nothing lifted, just a whole lot of mess. Ugh. We keep going. Look. Oh, those are inductors. Bunch of inductors. They could have used tantalums. They just could have. But they chose not to. Thanks for that, Apple. And look how tight quarters this whole area of the board is. It's kind of annoying, to be honest. You know what? I'm going to take my bent nose needle nose and I'm going to switch over to the straight nose because I think it's going to be easier in this tighter quarters here. All right, take a look at that. Everything came off. Let's get these little things out of here. All looks really good. I mean, it's good as far as horribly corroded caps go. I think I got them all. Let's just get this off of here. Come on, there you go. All right, so looking at this thing, It's ugly. It's real ugly. I think I'm gonna take these sims out. Are they metal or plastic? Can't really tell. Looks like it's got metal clips. Nice that they finally made that upgrade after countless busted sim sockets. Are these 1 meg? I think these are 1 meg sims. So this thing had a whopping 4 megabytes of RAM. But yeah, the reason why I took those off, I just wanted to make sure that we got good view of all this junk underneath here. And now what I want to do, and again, I don't know if this is 100% the right thing to do, but it's what I've been doing lately and it works well for me. So I'm gonna put some vinegar on this board. And I think that's gonna help with a couple things. It's gonna help eat away this blue corrosion that we got going on here. And I think it should also help with that kind of white salt stuff that we end up with all over the board from the leaky caps. Okay, like that. I was plenty generous. I gotta grab something to scrub this with. All right, just grab my toothbrush from upstairs. I'm just kidding. No, it's not my toothbrush from upstairs. Yeah, look, it's foaming up a little bit. Yeah, I think this is it working. I don't know. I don't know. If you have theories as to if vinegar is even the right thing to put on the leaky cap juice stuff, let me know. Put that down below. But see all that foaming that's going on? I mean, it's not a whole lot. It's not like battery leakage if you have NiCad batteries, but it's certainly something. Okay, and this is a very tight area over here. I'm gonna probably have to go upstairs. I have my my little anti-static brush up there. That one is, you can get in tighter spaces. It doesn't have the width here. Oh, you can't even see what I'm doing. It doesn't have the width of the top of the toothbrush there. But yeah, I don't know. I think this helps. I mean, this board needs every little bit of help it can get. As a recap, when I powered this, as a recap, pun intended, when I powered this board up inside a machine that had a good power supply, like I'd already fixed the power supply on it, it did nothing. It literally did nothing. Absolutely zero. So as for if that's a symptom of the fact that the caps are bad, maybe. Is that a symptom of the fact that the board is dead? Maybe. And this work that I'm doing right now is for nothing? Maybe. You know, that's it. When you have boards like this that are bad, you kind of just have to go out on a limb and do the recap, which unfortunately, you know, costs money. These caps aren't free. So doing this recap does take time and effort. And at least I can make a video about it. And if the motherboard is dead, well, we can try to troubleshoot it. But this VLSI chip right here, it does lots of heavy lifting. If that chip has a problem in it, I mean, there's no way to fix that. Not without taking it off another board. But look, that green crusty is mostly gone at least. So that's a good thing. All right, I'm gonna go upstairs. I'm gonna get the anti-static brush. I need to be able to kind of really get into the space over on this area here because I'm just having trouble really getting in there. There's that Motorola 68030, yeah, 16 megahertz, yeah. What's this, the egret chip, whatever that does. It's the name of a bird, right? Is that what an egret is? Oh, I'm back, and I was panicked for a second. I was like, oh no, I forgot to hit record on OBS. That would have sucked. Looks, a lot of the, it's all wet here because it's kind of soaked right through the board. So let me put some more on this one area since I have not got a lot of good scrubbing over here. Scrub-a-dub-dub. Got to get the corrosion out of here. Oh yeah. I mean, at least after all this, the board's gonna be clean. I mean, you can really get in there. See, like in there, oops, you couldn't see that because it was out of focus. Modem, printer, Anyhow, yes, I like to see that the green crusties have gone away, at least to some extent. Now, let's just take a look here. You can see that there's multiple layers going on, but look at that trace right there. See that? That's not good. That trace. Hopefully it's okay. Looks like it goes to this via right here, up to maybe that leg of this IC. So this is the kind of stuff you really have to look at very carefully, because if that's actually broken, I don't think it's broken, but if it is broken, you need to fix it. But you especially need to fix anything that's broken underneath the caps, because once you put a new component on, well, then we can't actually, we can't fix that anymore, can we? So you gotta spend it, sorry. So very careful attention to these little things under here. Very, very essential. Also, the connection from a trace to the actual pad is also essential, because sometimes it can break right there. Very hard to see. And like, look how this trace goes underneath there. So you can't really tone from here to, you know, you don't know what this even goes to. And that's what's annoying as well about this stuff. It's just a bunch of guessing. And the Amiga community has this PCB Explorer web utility. It's so helpful. You can like bring up a picture of the motherboard. You click on like that, like this little pad right there, and it will highlight the trace and tell you exactly where it's going. So it's very easy to troubleshoot, but I've never seen that for anything else except for the Amigas. And they're very lucky. And unfortunately, it's not even all the Amigas. It's only certain ones. But what a fantastic tool that is. So whoever in the community came up with that, props to you. Bravo for doing something that's super great and helpful for troubleshooting, especially on machines like the Amiga 4000, which has very leaky caps and is very problematic. So the fact that that tool's available is extremely nice. Okay, so things are looking a lot better. Let's flip this over, because I saw a bunch of corrosion on the back too. Oh yeah. So even though the vinegar kind of leaked through or onto the paper towel there, I'm just going to really give this thing a good scrubbing under here too. Just cover this up, trying not to splash. I'm trying not to splash vinegar everywhere. I just want to try to wash away that cap stuff as best as possible under here. It always feels good to clean yourself, doesn't it? Like you get in the shower, you feel all clean and nice. Well, hopefully this motherboard is gonna feel the same way after this TLC it's getting. Yes, sir, a little TLC. Okay. All right, well, not really foaming up. Not like it was doing on this side. Yeah, it was really foaming up over here, wasn't it? And doesn't seem to be, well, it's still doing it a little bit, but not as much. So I don't know if that means that, like, you know, we've neutralized things. We've neutralized this, those nasty leaky juices have been banished to some extent. Okay, I think I've done what I've done. I'm gonna take this upstairs. The camera's not up there. I'm gonna take this up there and I'm going to, well, first let me close this too so I don't spill it. I'm gonna take this upstairs and I'm gonna give this thing a thorough washing with warm soap and water, lots of scrubbing with the brushes here, and then I'll be back. I just need to clean up the vinegar that was all over the anti-static mat here. Don't want that getting back onto the bottom of the motherboard. Okay, that looks pretty good now. Give it a final wipe. This is the motherboard after washing and drying. Look at that. What a freaking transformation. Now, what always seems to happen is once I dry it, you get all this sort of white stuff in the IC legs there. What I'm gonna try doing this time is I have my washed toothbrush here. I'm gonna spray some 99% IPA here. And I'm gonna scrub this whole area here. And hopefully the IPA removes that stuff. Salts, I call them salts. Whether they are or not, I don't know. That's what I call them. So we're gonna go over, it only formed, by the way, where there was the cap leakage. So like on parts of the board where there was no leakage, like where over here, there's none. See, it's just perfectly clean. So that's why I'm gonna focus on the areas where there was cap leakage. And let's see if once this dries, does this actually work? Do the salts come right back? I don't know. I found in the past that using a cotton swab, I could kind of wipe the stuff away. So this time I'm just doing it en masse. and let's see what happens. And over here, it's gonna be the same. See, there's some underneath the IC right there. So let's just bathe this area a little bit. I don't even know if it's harmful at all, but I don't like it. I just don't like how it looks. So I'm gonna try to remove it if I can. And maybe this is the trick. So vinegar, washing, and then alcohol. Might do it. I prefer not to use alcohol if I don't need to. The alcohol, this 99% stuff is pretty volatile and it stinks up the whole place down here. So I'd rather not use it if I don't need to. But maybe this is the trick. Yeah. I mean, it looks good when it's wet, but that's part of the problem is things always look better when they're wet. All right, well, anyways, we'll let that dry a little bit. And now it's time to get these remnants, these legs off here. We got to get all of these off and clean up these pads. Now the pads don't look that bad at all, actually. They often can look far worse. So what we're going to be using here, soldering iron set to 345, this stuff here to clean the tip. And I need some solder here. So this is just my thin rosin core stuff here. And we'll keep this right there. I know you can't really see what I'm setting up here, but keep that there for cleaning. And we're gonna start getting these off. So I just apply heat and there we go. You see it's on the tip there, the little leg remnants. Now, even though I did a whole lot of washing here, it really smells like fish once you apply heat to these. And I think it's because the solder that's on there kind of absorbed. It absorbed a bunch of the leaky electrolyte, and it kind of releases it. I don't know if that's for sure what's happening, but if anyone has any better ideas, please let me know. Put some comments down below. But once you kind of get used to this process, you can make pretty quick work of it. I'm just trying to clean those off first, and then we're going to use solder wick to then clean them off entirely, and then I'm going to have to do some scraping. Although these don't seem so bad. Sometimes you have to scrape because there's a bunch of corrosion on the pad itself, and then fresh solder won't really adhere to it. So it's actually difficult to attach new capacitors. Look at this is going pretty quick. Yeah. All right, let's see. I guess while we're doing this, the board is drying and I'll be able to see if those salts are coming back. Now I'll have to reapply IPA anyways, oops, because of the flux I'm gonna be using. It looks pretty good though. I am shocked how good this board looks. All right, let's keep going. That came right off. Yeah, this, weirdly enough, the board looked kind of bad. Whoops, I'm making a mess of this. Come off there, there we go. The board looked kind of bad, but in reality, it actually seems okay. I've had some boards that were so bad. What was I recapping? Amiga 600, I think. Oh, wow, it was a disaster. And I didn't think the pads had anything left. Once I got the old caps off, I twisted them off. Nothing ripped off the board. But man, was there so much like gunk and junk left behind. Can you even see what I'm doing? Yes, you can. Just checking. I'm not looking at the screen while I'm doing this. I am just looking down at the board. Okay, so those are good. Get off there. Okay, there we go. So those are good. This one here. So you can make, once you get the hang of this, you can make pretty quick work of it. Now I get people asking me all the time if I can recap stuff for them, and I don't, unfortunately that's a no. I really struggle to keep up with just the work on the channel. I'm working on a video series for these machines and kind of repairing them. So that's why I'm doing this recapping work. Is that it? That's it. And scrubbing this with IPA did seem to help. Let's see, over here, is it dry yet? I think it's dry. I guess it's still wet a little bit. It's kind of sticky. Well, it's sticky where the flux is there. Okay, anyhow, next step. Got to grab the solder wick, which is somewhere on the bench here. Where is it? I don't know. I just had it a little while ago. Jiminy Cricket, where is it? It's around here somewhere. I can't find it. I was just using it. Well, when you can't find your existing roll, you open up a new one. That is frustrating to me. I don't like doing this, but I don't need to. Before I cut into this sealed bag. Really? Really? Yeah, I just like, I'm looking all around the bench here and I don't see it. So I guess I'm cutting into this bag here. That's really annoying. I like to keep this stuff sealed until actually time to use it. Anyhow, okay, chip quick. Use the good quality stuff. If you're gonna use this braid, you gotta stick to the good quality stuff. If you get the cheap stuff, it sucks. It absolutely sucks. Good stuff is night and day how good it is. So what we're trying to do here is get every last little bit of this terrible solder off of here. Come on. What's going on here? Oh, there was a little leg left. That's what was happening there. So the braid just makes very quick work of it. This is good. I like this stuff. I've always used MG chemicals, and this chip quick. This stuff's nice. I'm impressed. Okay, so you see that? It's making those much cleaner. Okay, well, I'm actually happy that I bought this stuff. I got it from Amazon, I think. So yeah, we're just trying to get the nasty corroded stuff off. And you do that, and I'm just kind of wiping it on the pads here. Again, you kind of got to be gentle. You don't want to use force, and if it does stick, you got to heat it up. Don't pull up, it's going to rip the pad right off. Look at that. Very nice. Very, very nice. Okay, now over here in this area, I'm just going to cut off the used bit here. Okay. It's weird, I kind of like this stuff, but this braid seems, the braid here seems very fine, but at the same time, it actually seems a little harder to use than the MG chemical stuff. Since I can't find it, I can't tell you what model number that is, but this really does clean these pads really well. Loving that. Loving that. Okay, and this one up here. Oh yeah, oh yeah. It's a little tight quarters in there. But check that out. Wow, it looks better on the camera than it does in my actual eyes. The shadow up here makes it a little harder to see. All right, and you come clean. Oh yeah, you look good. Look at that. All right, what am I gonna do? I'm gonna use cotton bud here to just clean up. Actually, you know what? Yes, I am gonna use the cotton bud here and some 99% IPA because that kind of gunk gets all over the place, and you'll see, watch this. It'll all come off on there. See how it's kind of darkened? And look how shiny and nice those pads look now. That's what you're looking for. If you don't get the shiny niceness, you gotta use a little scraping, a little physical abrasion on them, just to make sure that when you go to attach the fresh new capacitors, that everything adheres properly. That's what you want to see though. Looks real good. I'm just, oops, I bumped the camera, sorry. I'm inspecting the traces. I'm using the camera view now because it's magnified. Everything looks really good. Again, you want to take a special attention to what runs in between the cap there because I'm going to cover that one up. But stuff that's around it, you know, you can fix that after the fact. So it's not the end of the world. I'm just wiping this off with the cotton bud. Yeah, it's pretty clean. This particular wick, this stuff here, doesn't leave a lot of residue. I like it. I like it a lot. Okay, over on this side here, let's Let's do the same thing, a little 99% IPA. Not the beer variety, but the alcohol you cannot drink. And again, we're just gonna clean everything up here. Want it to look spick and span, and it does. I mean, look at it, see, very dark. We're just getting all that gunk off. A lot of that comes from the rosin that's inside the solder wick itself. But I think some of that is the corrosion as well. But yeah, so where's my pick? So look at this trace right here. See, it's okay. See how it connects right there to the pad? Sometimes that break can happen right there. And then you actually, you don't have continuity from there to there. But this looks really quite good. I don't know what that is, a little bit of fluff there. Only thing that's, again, that's the only thing right there that looks a bit, oh, you know what, look at that. Just rubbing that made it kind of come clean. That trace just looks a little slightly suspect there. Let's just do that again. Could just be like stuff on the top. Yeah, look at that. Look how just rubbing it there. Now it looks fine. Yep, I'm not too worried about that. Nothing around here looks suspicious when it comes to bad connections. And that can definitely and easily be a real problem. Mac 2CIs, they really suffer. They have a lot of caps all in one area, and it just wrecks it. When you have them all leaking, you get a ton of corrosion. Sometimes the chips fall off. You have like packages like these ones here, they just fall right off the board. They might be missing. You have to reconstruct that whole area, and it can be quite an ordeal. This one though, I'm liking it. I'm liking that a lot. I'm just gonna blow this off with my air blower to dry this alcohol because I want to put flux on next, and I just don't want the IPA to be left over. All right, a quick blow dry later, and look at that. Now you can still see like the mask here is all like weird looking, and that's not gonna go away. But things look pretty good on the chips when it comes to the legs. I don't see a lot of that white salts. This one is not, that one is not the best. So what I'm gonna do is when we attach new caps, then I will try to clean this extra with the cotton swab and some more IPA, just to try to get those legs looking a little shinier on that. I have a feeling that, oh, that's just, this looks like just a regular LS part here. I wonder if that's like for the serial ports or something like that. Anyhow, okay, next phase. What I like to do is take this rosin flux and I just put a dot of it to make sure I'm looking. I have two of these. One is flux. There we go. I put way too much there. One is flux and one is bearing oil. I just need to make sure it says flux because it's the same color. It's just this kind of dark color. That was way too much flux right there, but it's not a big deal. We'll clean that up in a sec. I just like to put a dot in between each one of the caps, so when we go to solder it on, it just makes it a little easier. Okay, let's get some of these. What are these? These are the 22s. So these are in place of the 1s, or 10s, I mean. And I got to get my phone out so I can look to see. Let's see here. Oh, well, that's a great photograph. Seriously. Huh. Okay, luckily, okay. It's just barely readable. Okay, well, anyhow, let's grab some tweezers and start placing these parts. So these aren't, oh, these are weird tweezers, okay. These are not polarized. So I'm putting these are the 22s, so they're going in anywhere where the 10s go. So 10, 10, and 10, okay. And I think over here, it was 10, 10, and 10, okay. Oh, I got too many of these out. 10. Cool thing about this rosin flux, it's very sticky. So when you drop these into place, they don't really move around either. 10, 10, 10. Okay, there are all the 10s placed. I'll do those ones first. So the good thing about this rosin flux, oh, you know what I'm gonna do? This is my warning to anyone working on these boards. If you have SIM slots, put tape over them. Do not drop blobs of solder into your memory slots. It is a freaking nightmare, and you will thank me. So put the tape on there, please. So the good thing about this rosin flux that's on here, all you need to do is just put some solder onto the tip like that, and then hold down the cap with the tweezers, like so. And then you just touch it here. So the solder that's on there mixes with the flux that's on the board, and then it just sort of holds the part on. It's super handy, very easy. Now, personally, I am not a stickler for perfect alignment. I don't care at all. Some people, it drives them crazy when it's not perfectly aligned. But, you know, I don't. So what I'm trying to do is I'm just attaching one side. I'm not really putting enough solder. I'm just putting something on there enough that it holds it in place. And then I'm going to go back and I'm going to apply a more appropriate amount on both sides. So this is all you do. It's you just have to be methodical about it. There we go. But see, those caps, they're held on there. They're not going anywhere. So I can flip the board around and we can do the other side pretty quick now. So we'll just keep going. We're going to do all these 10s first. The reason why I'm starting with these is they're low profile and they're not big. So they're not going to like block access to, like for instance, that cap right there, this 47. Sorry, that was out of focus. The 47 up near the ADB port here, it's just not a lot of room. So if, you know, once I put that on, I don't know, I could have put that one on first, I suppose. Let's get this one straight. There we go. I mean, this is good enough for me, honestly. And this one here is a bit hard because the slot is there. That's the slot that holds the FPU. All right, so all of those are attached. Let's grab the 47s next. I'm gonna try to wrangle the mess here that is these. And look, I wasted a couple there. It's not 47s, the 47s are here. Boy, I don't have many of these left. I had a lot more of these. I've been recapping stuff, going through these a lot. And these are very expensive, these caps. These were given to me. They came from, like, the reason why these bags have like BOM numbers, this was from some project or something like that. So I've been just slowly using them up. Come on. Wow. Eventually I'm gonna run out and I will just buy some regular aluminum style ones because obviously those won't have the issues that these have with the low values and things like that. And these are so expensive. So if anyone has any of these floating around, especially like 16-volt caps, they're the MLCCs, and you don't need them anymore and you'd like to donate them, yeah, feel free, because I'll definitely use them up. But on the other hand, I don't know if I'll ever buy some of these because they're just so expensive. Yeah, I think I went and looked at the price and I had like massive sticker shock. I was like, what? No way. Oh, that one's very crooked. It's so crooked, I'll even fix it because it looks so bad. All right. All right. Oh no, it was better and then I ruined it. Okay, whatever. Good enough. I should just place these. Speeds up a lot of the time if you just put them in the spot where they're gonna go. This one goes there. Boop. Okay. And this last one here, no, it's not the second to last. Okay. These are getting sticky. One last little blob of solder on here for this one, which sort of moved off to the side. There we go. Okay. So all we got left, are the ones, which are just 2. And I'm just going to double check on my phone. So on the phone here with this horrible picture I took here. So let's see where we go. Let's see. So over here, that's a 1 with the black facing the right. And this one here is a 1 with the black facing to the left. And the plus matches on that one. So the plus should go to where it doesn't have the black mark. And the same thing here. The plus is right there. So, okay, so that's a 1. That's a 1. And looking here, that's the 2 that I haven't installed yet. So good, I didn't screw that up. And over here, I'll just double check. 10, 10, 10. Okay, we're good. It's always worth double, triple checking. You know, you don't want to put the wrong values. It just causes more troubleshooting later. That can be really annoying. So I don't have a whole lot of these left. I just have these 2. And I don't have any MLCCs in this really small value. Be nice to have some of those. Although there's no way this thing runs at 50 volts. I don't know, these are probably, oh, I guarantee you actually, yeah, I'm pretty sure this is going to be for the audio, both the input and the output. That's why there's 2. And on the old Mac Classic, there was only 1 of these. Okay, let's just figure out, I'm just got to pay attention here. That goes this way. So the black mark, which is the negative side, goes to the right on that one. Oops. Okay, and for these, so I'm just going to pick it up and try to get that in the right spot. Okay, that one is attached. Anyways, what was I saying? I got interrupted. So let me just make sure the right polarity. Yeah, plus there. Okay. So with these, I'm quite sure they have to do with the sound chip, which is this thing, right? DFAC? I don't know, actually. Where's the sound chip on this board? Oh, maybe it's not that. Maybe the sound chip is in this thing now. I don't know. Well, anyways, I think the audio circuitry requires these caps to protect the audio input. So these caps are there in series with the audio input and output, I would presume, to do filtering on the audio signals so that you don't have any DC kind of coming through and potentially damaging the chip or whatever. So I'm pretty sure that's what's going on there. So the reason why you lose sound when these caps fail is because they go open. And when they go open, you actually, they're like as if they're not there on the board at all. They're like removed from the board essentially. And because of that, you don't get any sound at all. And this thing has mono audio. The in and out is just mono. So that's why there's only like 1 of each. And I think if this was stereo, you'd have probably 4 of those. All right, so now we can go through and do the rest of these caps. So I'm just gonna do a proper amount of solder here. So we're getting that there in the right spot. We're gonna heat it. And I will apply plenty of solder. And I'll go back and do the other side so it has the right amount. Because right now, it does not have the correct amount. That one's not quite in the middle, but whatever. It's good enough. So this one here, heat that up. There we go. Hopefully I'm doing this in camera. Yes, I am. Just checking. Sorry if it's out of focus. Again, I'm not looking. I'm just doing the work, looking directly at the board. So with these caps, you want to have a nice little like round, shiny fillet. I don't know if that's the right name. I'm just going to say it is, but I have no idea. So like there, nice little round fillet. It's on all of those on the right side. That's good. Moving on over. Hopefully it's in camera. Yes, just checking. Just apply the right amount, the perfect amount of solder to these. The flux I put on there really helps out. Don't want to melt things here. Whoa. I feel like I was touching the plastic there. Okay. So that's good. These are good. Maybe a little more here. Okay. I just like to kind of see it all the way up to the top edge. And I'm not seeing that on these. There we go. I want it to be shiny on the top there. And I have that one I got to do. Okay. Over here, those look good. I mean, it's messy, but it'll work. That's all that matters, right? Let's not forget this one at the top here. The one that is turned 90 degrees from the rest. Okay. Now we go back and we redo the first ones I did because I didn't really put enough solder on any of these. They were just attached with what was on the tip. So we're just going to reapply. Make sure it flows well. Okay. Don't forget this one. And these guys over here. Get flowed, guys, get flowed. I want you to be nicely attached to the board so you're not going anywhere. And we'll just check these here. Okay. And this. Okay. I think that's it. I think this board is recapped. Just need to clean it now. Yeah. So that's the 47. That's a 47. And that's a 47. And then these sort of brown color ones are the 22s. And then that's a 1. That's a 1. Yeah. Sweet. Okay, so got to get some fresh cotton buds. You don't want to use a toothbrush for this cleaning because that doesn't really pick up and take away. You don't want to remove the flux that you've put on here. So that's what we're going to do. You'll see when I use the cotton bud, it's going to start turning kind of yellowy color as it picks up all the leftover flux that was left behind. Now, flux is not bad for the board. It's not like it's going to cause damage to leave it on there. You can see like Commodore 64s with tons of flux on them. And I mean, it didn't cause an issue, but it's a little unsightly, so you might just want to clean it up. A little bit at least. Now they have like things like flux remover, which is a fancy, expensive chemical. I don't have any of that. I don't really want to use that anyways. I'd rather just use this cheap stuff that I got. And yeah, there we go. So that's looking pretty good. Now, once I've sort of picked up some of the flux on this, and that's why it's turning yellow, we can use the toothbrush on this area. Oh yeah, I was gonna go back over this chip here, wasn't I? Because it looked a little sketch. Let's just focus on its legs here. Looks okay. Now, as I mentioned, when I powered this board up originally, it did nothing. Nothing. Black screen, no garbage, no nothing. I think that's okay though, because I think, you know, some of the systems like Mac SEs, for instance, even when the CPU is not running, you still see video. And that's because the part of the motherboard that generates video is not reliant on the CPU. I'm pretty sure on this board, it is. The CPU initializes the video circuitry, which is going to be in this chip here, or maybe that chip there, or whatever. I don't know. No, that chip there is the SWIM, the Super WAS Integrated Machine. I think it's, no, IWM, Super Integrated WAS Machine. But then, for whatever reason, they changed it from IWM to SWIM. But anyways, that's what that is. I think this chip does everything, including the video, on this board. So yeah, without the CPU running and kind of initializing with the ROMs, you really aren't going to get anything. So if you have cap problems that are resulting in, say, you know, the CPU not executing correctly because the voltage rails aren't stable or whatnot, then that does cause issues. Now we may recap this and find this board totally dead, and all of this work and the money spent on these caps would be a waste. And that's the problem when you have boards that need recapping, is you don't really know if they work, and they may not. And then you're up a creek. And like, what are we gonna do? Find one of those chips to try to replace it? That's not happening. Oh, there's some of that stuff there. Let's get that off, some of that white stuff on that chip. Let's get that out of there. Get out of there. Anyways, yeah, so that's the problem with boards. If you can't know it works first, it's pretty disheartening when you do finish and then it's totally dead. But it can happen that way. All right, I think we're there. We are there. Yeah, I'm just gonna, let me get the air dryer, blow this off so it looks nice and dry so we can do the final inspection. So that is one recapped Macintosh Classic II motherboard. It's a little sticky because there's still flux on there, but I don't care. It's good enough for me. Let's peel this tape off here. The Sims were protected. Oh yeah. And over here, looks good as well. I mean, compared to how this looked, all that junk that was on here with, look at this, look at this, look at this mess here. All this stuff. There's more of these. These things, they just dumped all over the board, tried to ruin it. They're never gonna cause that to happen. Hopefully the new electrolytic caps I installed here, the two that are on here, aren't gonna dump their guts like these, at least not in my lifetime, but you know, they might, because who knows, everything is not made as good as it used to. But it seems like those 90s caps, when is this thing even from? Well, these chips say 1991. And it's funny, these are EPROMs. Isn't that weird? Apple used actual EPROMs? Like, doesn't that seem like a lot of extra work? There's one there, 91. 31st week, 91, I think, on that chip. A lot of these that at least I don't see, there's no date codes on a lot of these. Anyhow, yeah, so hopefully this thing functions now, and it certainly looks a whole lot better, and I hope that, straighten that out. Hopefully these don't leak, and of course those will never leak, and hopefully these other chips actually work and this board is functional. But you won't be able to find out in this video. You're gonna have to wait until the video on the main channel where I actually put this into an operational chassis and then we see if we have a living Classic II motherboard. This is a wonderful upgrade to a Classic. If you have a Classic that works, like the power supply hasn't spewed its guts all over the place and it does function, these Classic II motherboards are a really nice upgrade. So if you can find one that's bare without the rest of the computer, or you can find yourself a computer, it's a very nice upgrade. They're not as good as the SE30, but I don't think these cost as much as the SE30. And the SE30s, well, they got their own problems because the motherboard also eats itself because of the capacitors. But yeah, it's a big performance improvement over the regular Classic and all the other 68,000 based Macintoshes. But on the other hand, I have such a hard time recommending anyone get a Classic because they're just so problematic when it comes to the caps on the motherboards, which are always bad. And then the caps in the power supply, which are always bad as well. And depending on how leaky these get, it can ruin traces on the motherboard, it can ruin traces on the power supply, it can ruin components on the power supply. The cap juice on the power supply gets into the voltage regulator and can cause the voltages to go all out of whack. So yeah, I don't love Classics. So while they're cheap, you just need to know what you're getting when you get one of these because you're gonna have to do some repair work. And if you can't see it operating, like with the picture showing a boot screen, then at least you know, just need to do some recapping and it should be good to go. But if like this one, it was just dead to the world, well, you don't know, like the battery could have leaked and just took this whole board out. So buyer beware with these, really, buyer beware. Anyhow, I hope you enjoyed this recap of this board. I'm sorry I couldn't try this out. Like I said, you'll have to wait for the main channel video where I test this out. And I feel like a bit of a tease here, but I just don't want to give away the outcome because I want to have that like excitement of, it freaking works, or, oh, it doesn't work when I actually put this into the chassis. So I myself, I'm not even going to test this right now because I'm going to go to bed shortly. I'm not even going to work on the rest of the Mac. And yeah, I guess we'll find out together when it comes to the video. But I am very pleased with how this looks. This board looks really good now. I'm very proud of my recapping work here. It's clean, it looks good, and everything I did here, you could do without any special tools. I didn't use like a sonic cleaner. I didn't use like fancy desoldering irons or any of that stuff. This is just simple stuff. A pine sill, tweezers, rosin core solder, some rosin flux, and then of course this Chemwick stuff, which I just got off Amazon. I mean, it's not cheap, but it's not that expensive either. And you saw that made really quick work of this board, and it looks freaking great. Oh yeah, and a bunch of soap and water and vinegar and stuff like that, but you know, scrub, scrub, scrub. Anyhow, if you like this video, thumbs up. If you didn't, you know what to do. Thanks to my patrons. Their names are scrolling up this side of the screen over here somewhere. And they get early access to videos and other behind the scenes stuff. And yeah, that's going to be that. So stay healthy, stay safe. I will see you next time. Bye.